Good morning everybody. Physics, IGCSE, and we are now busy with forces and matter, which is chapter 5, the beginning of chapter 5. So, please study section 5.1 first and pay special attention to the table marked 5.1 and figure 5.6, which is the graph. Make sure you understand that, then do question 5.1. So pause this video and do that before continuing. Okay, right. Okay, we continue now with section 5.2, and the main thing that I want to get across is the drawing of the graph and the setting up of a table and drawing a graph from the table. So we're going to do question 5.2 as an example. Okay? So the first thing you have to do when you do this work, you have to follow steps for drawing a graph. Number one, your first step that you must do is you have to complete a table. So you've got to put your data in a table. Okay? The next thing that we have to do, we have to determine the independent variable and the dependent variable. Okay? And alright, I think we're going to do this as we go through. So let's first complete the data in the table. The table is given there in question 5.2. It's marked the load in newtons, okay, and it's 0.0, 1.0, 2.0, 3.0, and so on. Then the length of the spring is in millimeters, okay, and the spring originally was 50 millimeters. Then it stretched. As the load was put on, then it became 54, then it became 58, and then it became 62, and so on. Okay? So what was the extension? We only measure the extension of the spring. In other words, how much longer does it get? We got to subtract the new length from the original length. Here's the original length is 50. This is 0 extension. Here the extension is 4. Here is 58 minus 50 is 8.0. And 62 minus 58 is 62 minus 50 is 12.0. And so you carry on and you complete that table. Okay? Right. Once you've completed the table, now we can start setting up the graph. But let's just talk a little bit about the variables here. All these experiments work this way. You put something in and you get something out. Okay. That which you put in, you have control over. So you are putting in a load. You want to know what the extension is. You don't have control over the extension, that the spring does. But you have control over the load. So this is called the independent variable. Independent. Variable. It does not depend on any other thing in the table. It depends on what you put. You can decide what it is. This extension is dependent. This is the information that you want to determine. So this depends on that. This depends on that. So whatever the extension is depends on the load. And you have to, every time when you work out the extension, you subtract the original length from the new length to get the extension. Okay? Right, now for the next step, to set up your graph, you need a graph paper, or you can use paper with blocks. Okay, so I'm using this this type of book with blocks in it, and I'm working with the dependent variable on the short side and the bottom, and the independent variable with the long side and the top. So now we have to mark our axes, and we have to determine our scale. Because we are always using the decimal system, try and keep the scales in multiples of 10. That's the easiest. So if this is your vertical axis, and this is your horizontal axis. On your horizontal axis in your table, you have the load goes from 0 to 8. Okay? But so we're going to mark this from 0 to 10. So count your little blocks. If you don't have graph paper, all graph paper is marked in little blocks, okay, like this, little blocks. So every 5 blocks, the line is a bit thicker, okay, and every 10 blocks, the line is thicker still. So if you don't have graph paper like that, we're going to use the block paper, and we're going to count the blocks, and we're going to draw the lines. So what I've done is I've said, let us count up to 10 on the bottom. How far is 10? You will see that if you count the blocks, the little blocks in twos, you will reach 10 almost at the end of the page. Then means that there are 20 blocks. Halfway is 10 blocks, but we call it 5 because we want to use the whole scale. Okay, so these are now 1, 2, 3. These are 10, and every 2 blocks. Every 2 blocks is 1. Every 2 blocks is, then it's 2, then it's 3, then it's 4. 1, 2, 3, 4. This one will be 5, and so on. Okay. So mark on the bottom of every 2 blocks, it must be 1 Newton. Okay. And here we label load / Newton. Okay. And then on the top, so what you can do now is you can see each 5 little blocks, you can actually draw a pencil line in. Do this in pencil so you can rub it out. So here's 1, 2, 3, 4, 5 little blocks. So we can draw a pencil line over the line to help us to navigate this paper. And at 5 you can draw 1. Okay. And then between 5 and 10 you're going to have another one. Every 5 blocks. Okay. Like that. So now you've got your horizontal axis divided up into every 5 blocks a pencil line, and we mark the second one will be 5 and the last one will be 10. Okay? So now you go to your vertical axis and you see what your data looks like. Where's your data going on the vertical axis? That is the extension. It goes from 0 to 26. So what we do then is we say from 0 to 30. So we're going to mark 10, 20, 30. 10, 20, 30. So you must organize it in such a way that you can again still, every 5 blocks, you can draw a pencil line like this. And this 5 blocks will be on 10. And there will be another 5 blocks here, and then this will be on 20, and this will be on 5 blocks will be on 25, and this will be on 30. So this will be on 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and yeah. This first line is actually going to fall between 4 and 6. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18. So this pencil line is actually halfway between 10, which is between 4 and 8, which is 4 and 6, which is 5. This is how it works out. Okay. So whatever you do, make sure that you use multiples of 10 and that you mark the correct marks on here and try and use most of the scale that you've got. Okay. Right, we can label that axis. We've now got to label the y-axis or the independent variable, which is extension in millimeters. And now we must give the graph a heading. I've called this graph the relationship between load and extension for a spring. Simple. That is what you can see from the graph in any case, because we don't have more information, we don't know what spring it is, where it came from, etc. Now we can mark our data points. So you have to do this very precisely with a sharp pencil, and where the lines cross you make a very small X. Right, your first data point has got a load of 1 and it has an extension of 4. So we're going to make a cross there where load 1 and extension 4 meet. Then again we've got load 2, extension is 8, so it goes there, and load 3, extension is 12, and it goes there, and load 4, extension is 16, and it goes there, and load 5, extension is 20, goes there, and load 6, extension is 23, 6 extension is 23, which is going to be somewhere there. Sometimes you have to estimate these. Sometimes it's in between two lines or in the middle of a block. Just estimate it, but make sure that your estimation is correct. That was 6. Then for 7 is 25. 5, 6, 7 is 25, which is halfway to 30. And then 8 is 26. 5, 6, 7, 8. 8. actually 8 is here somewhere. There's 26 somewhere here. And then take a ruler and put it on the 0 here where the two axes meet, and every cross as far as it is a straight line. And you'll find that the first 2, 4, 5 crosses fall in a straight line. 1, 2, 3, 4, 5. They fall in a straight line. So then you can draw a straight line with your ruler. The others, they curve. So you can either connect each dot, or if you're good at this, you can just draw in a curved line there like that. Okay. And that is how you draw, put your data on a graph, and don't forget the steps. Number 1, complete the data. Number 2, determine the independent and the dependent variable. Number 3, mark the scales on each axis and label them. Number 4, give the graph a heading, and then number 5, put in the data points. And number 6, then you can connect the points. Okay, now you must do question 1 and question 8 in the end of chapter exercises, because they are very similar to this. Thank you very much. Good. Okay.